Okay, good day, and we have the relationships between load, shear, and moment in beams, no? Ang Now, we consider the beam, no, which is loaded with a uniformly distributed load of a load intensity of W over a length or a span of L. So, cutting the beam, no? So, we have a cutting section, AA. Then, we consider the part of the beam at the left, no? Okay, so, we have the reaction at the support, and if this is loaded, this is supported with a hinge and a roller, a simply supported beam, then this load here with a resultant of WL will be equally shared by the two reacting forces. Okay, so RA has a value of WL over 2, and ang imuha karong load dire due to the uniformly distributed load because this is located at a variable location X, no? So this is a product of W times X, no? Load intensity times the length. Okay? So how about the shear? Shear is the summation of forces acting vertically. Okay, so we have RA going upward. So RA will cause a positive shear and subtracted with the WX causing a negative shear, di ba? So you have on sa WL over 2 for the RA and then minus WX. Okay? Then moment, so this is the shear equation and this is the moment equation. So for the moment, so ang ato karong RA can produce what kind of movement? The bending will be like that, no? So it will bend upward, no? So which means this is a force causing a positive bending. So REX minus, so kinisad will bend your unsa beam in a downward manner, so muni mo produce og negative shear, no? So a negative moment, I mean, no? So RA with the moment arm X, then the moment arm of the WX is X over 2. So imo na i-multiply, simplifying. Okay, so we have WL over 2 times X, or I'm substituting the RA which is kane, na? Then times X, then this one, this is WX with X over 2. No, so this is true for values of X from 0 up to L. Now, how about if we have to differentiate the equation for V and M with respect to X? So, we are interested to get their slopes, no? Or to get their rate of change, no? So, if I have a slope of the shear, no? So, I'm going to take the dV dx, no? So, we have a V equation. Where is our V equation? This one. Okay, so muna siya. A constant term with minus Wx. The derivative of a constant is 0. The derivative of x is 1. So, what is left is only a negative W. Okay? Now, if we have moment equation, the moment equation is this one. So, that is the moment equation. Ako lang i-copy diha. And if that is simplified, I can have the constant coefficient of x, then kana I also have the x squared term with the constant coefficient of W over 2. If differentiated M, no, taking the derivative of M with respect to x, no, so this becomes 1, no? So if this becomes 1, so the constant coefficient will be the derivative of your first term. The derivative of x squared is 2x, so 2 is eliminated, so what is left is Wx for the second term. Now, examining this two result, no, the derivative of V with respect to x, which is minus W, it is actually the load, no? So, ang imo dae karon nga slope sa imuhang shear is actually taken from the load, no? Kung unsay load nimo diha mo na iyahang slope of the shear diagram, no? And then sa imo sang slope sa imuhang M, no, or moment, so this is actually your shear. This is a shear na asam to tong shear. This one, no? So ang ato ding shear, kung unsa iyahang value, mao na imong slope sa imong M. Okay? So ato nang timan-an, no? So ang ato di nga M makuha nato ang iyang slope gikan sa V. Ang slope sad sa imong V makuha sad nato gikan sa iyahang load. Okay? Now, actually mao na siya. So, derivative of M with respect to x is V. Thus, the rate of change of the bending moment with respect to x is equal to the shearing force, or the slope of the moment diagram at the given point is the shear at that point. No? So, taking the slope of M, then just try to go with the shear on that point. If you go with the slope of your V with respect to x, then you can also consider the slope. Now, here are steps on how to come up with shortcuts, no, in having the shear and moment diagram. Okay? The area of the shear diagram to the right or left of the section is equal to the moment of that section. So, gikan sa imong shear, you can have the moment. Okay? The slope of the moment diagram is the shear at that point. Mo na itong ingon ganina. And the slope of the shear is equal to the load of that point. The maximum moment occurs at the point where shear is 0. When the shear or slope of the moment diagram is 0, the tangent drawn to that is horizontal. So there will be a figure later at ipakita, no? This relating with this, no? When the shear diagram is increasing, no? Panalitan imong slope is increasing or imuhang shear is value is increasing, no? The graph kuno of the moment diagram can be a diagram that can keeps upward, no? Okay, so when the shear diagram is decreasing, so panalitan imo habang karong shear gay ana ba, no? So magkadako yang value. So sa ato pa kung increasing ang concavity sa imuhang moment paingana. Okay, so more example ato na ipakita niya tanan. When the shear diagram is decreasing, no, kung decreasing imuhang shear diagram, the moment diagram will concave downward. Okay, so let's have some example and we will be applying that one. Okay, so here is a figure there relating with this, no? Now, if this is the graph of your M, no? This one. So, if you draw line tangent to this, no? Makita nimo nga ang imong tangent line kausab-usab, no? The inclination of your line is actually changing, so its slope is also varying, no? So, pananglit gayon ana. Unsa man imong slope, is it increasing or decreasing? So, ano nimo pag-ila? Primero, gabarog. Sunod, nagbarog, pero saman, ni-decrease yung slope. Unya, makita nimo dire that the position of your line now becomes on sa horizontal. So, kung imong hunahon primero nagbarog, then horizontal, then sunod ni dungo, unsa man, increasing, decreasing. So, obviously, that is decreasing. So, ang imong dm dx is negative. So, meaning, ang imo karong V is decreasing. So, when V is decreasing, asa man to dapat ka-mention siya. When V is decreasing, the moment diagram will concave downward. So, ari ka, imong tan-aw nimong shear, kung nag-decrease yung value, then the concavity of your moment diagram will be downward. Pero kinel, you try to look at this. How the slope of your tangent changes, no? The slope of your tangent, tingnan na. So, nag-usab-usab yung inclination, right? So, this is a line containing a negative slope, di ba? Negative slope na siya. Pag abot dire, nahimo nga sa 0. From negative to 0, meaning, nagsaka imong value. And from 0 to a positive, so that means the slope of your moment, no, is positive. So, meaning, V is increasing. So, when V is increasing, the moment diagram will concave upward. Pero if there's a point here wherein the tangent drawn is horizontal, no? Nag-mention na diri ganina, the maximum moment occurs at the point of 0 shears where the shear is 0. That is when the tangent is horizontal. No? So, in our calculus, we know that we have a maximum and a minimum point. Di ba? So, kung ang imo karong tangent is horizontal, meaning the slope of which is 0, so meaning ang imong shear is 0, so you were able to have the maximum point. In our calculus, no? So, kana, nag-horizontal tangent man sa ka. So, ang imong shear diha is also 0. But sa atong moment karon diagram, kini man atong gitawag og maximum moment, kini maximum gihapon ni dito sa atong moment diagram, only kini bears with the positive value, kini bears with the negative value. Na akong lang gibutangan maximum at negative value, kini maximum wherein it bears with the positive value. Okay, kung ang imong moment is maximum, ang imong moment is positive, the bending ra mo na imong tan-awon sa beam, the bending will be that way. No, but if the moment is negative, then the bending will be like that. Okay? So, we will be using that one in having our shear and moment diagram. So, ato sa of course, doon na load ihatag. Okay? Now, you are asked to give the shear and moment diagram without writing the shear and moment equation same as what we discussed previously. Then, indicate the values of moment and shear in all points of change in loading and at 0 shear. Now, then, give the maximum shear and maximum moment. Okay, manangliting ini. So, human diritso, no? Okay. So, usually, the given here is kana. Now, this is taken from Strength of Materials, no? Singer and Python, page 113. This is a sample problem, no? Ingani. So, usually, the given is the beam loaded with a uniformly distributed load, okay, then a concentrated load, and the supports are here. So, this is an overhanging beam, no? Ingani. Now, usually, you have to start with the reaction. So, sa ato pa, kini, this is not part of the given. So, you need to solve this, no? So, asay mo solvon, atong tanawin yun sa pagkuha. So, solving for the reaction, say I have to solve for the R2. R2 is here. So, I have to take moment at B. Correct? Okay, moment at B. R2 with a distance of pila? 12. The rotation is counterclockwise. Pangana. Now, kini, clockwise man eh. Kining imong uniformly distributed load will also take a resultant, no? Kung ari ko sa B, then the moment of which is also counterclockwise. So, same as this, no? Clockwise, same as this, no? Kani mo ay counter. So, any moment produced with your R2, ato lang i-balance with the moment produced by the concentrated load and the uniformly distributed load resultant. Okay? So, yun eh. 8 times 9. That's 9. Okay? And we have what is the resultant for this? If that's 2 and this is 12, so that is 24. If this is 12, then it is located 6 meters from both ends. No? So, 6 meters dire, then 6 meters dire. But I have 3 here, so sa ato pa, 3 meters from the support is the location of the resultant. So, this is 6 and 6 on the other side. No? So, this is the resultant of the uniformly distributed load of 24. So, 24 times the distance 3. Calculating, we obtain the R2. Okay? Now, if you take moment at this, so, the forces involved are R1. Open the value, we are solving for this. R1, rotated, clockwise, and these are the forces, no? Concentrated with a resultant of the uniformly distributed load wherein the rotation is opposite to the moment produced by your R1 with respect to moment center, which is D. Okay? So, R1 times 12, then, P or 8 times 3. 3 man eh. Then, 24, 6 plus 3, so you have 9. So, there you have your R1. So, R1 is 20, R2 is 12. Now, we can proceed directly with the shear and moment diagram, no, by just considering loads, no? So, pananglit kini. Our load dire is 0 because ang atong load diha varying man na siya from here as you increase, no? So, magsaka imong value. Now, what is the resultant, no? If you have to get the area for this, no? Diba, this is 3 with the load intensity that is equal to pila? 6, no? Okay, that is 6 kilo Newton. That is 6 kilo Newton acting downward. So, ang imong shear ana is a negative shear. So, ibutang diretso, you have negative 6, no? Unsa may slope ini? The slope of this is 0. And if you have to consider that there is a cut section here at a distance of x, no? So, ang ato karon nga resultant as it goes there, no? Or ang imong force, no? So, magsaka, so, based on the value of x because the resultant would be wx, no? So, that is a linear function of x, no? So, that means this is just a line. So, kung first a 0 degree imuhang slope ini, then dire first degree ka. Okay? So, next, okay, minus 6, So, you can have the minus 6, no? But there is a concentrated load dire. The concentrated load will cause an abrupt change in the shear value. Minus 6, this is positive man upward, no? So, we have minus 6 plus 6, maabot kag 14. Niya kinenaan naman sa uniformly distributed load, no? It is a distributed load all over here, no? So, that means ang imong resultant ini is the product of 2 and 9. So, area ini. 2 and 9, if you multiply, is 18. That is downward. So, negative 18. So, if I have 14 minus 18, munang mugawas, the result here is negative 4. Again, that is a 0 slope. So, you can have a first degree slope. No? So, kung first degree na, so dire will come out to be a second degree. No? So, pasakan na siya. 0 degree, then first, then second degree curve. Okay? Then, I have negative 4 here. at the location of C, and there is a concentrated load, no? So it will cause a negative shear, correct? So minus 8 combined with negative 4, manang mo arrive kag negative 12. And there's no load here, so that is constant. Ganina, mausab siya linearly because the load is uniformly distributed. While here, there is no load anymore, so it is becoming constant. Okay? Now, as you see, ang ato ang mga region here are marked as 1, 2, or area 1, area 2, area 3, area 4. Okay? So, you have to go, by the way, naapatay importanteng kuhaon di ay, no? So, you have to solve for the location of a point where shear is 0. From 14 to pila, negative 4, it will pass through a point where the shear is 0. Diri, mag-0 man imong shear. O saan nimo pagkuha sa location which is kini D. So, you need to solve this, okay? Now, you have two similar triangles. Pwede kag mag-ratio and proportion. Yeah? But, pwede sa magkuha lang o sum of forces acting over this region. If this is a shear of 14, niya musero siya due to the load above dire. Correct? So 14 up, then downward dire, o sa maimong load pa dong dire. If initially we do not know, that is D. So D times the W of 2. Correct? So 14 minus 2D is equal to 0 shear. Okay? So yun. So, actually, mag-ratio and proportion gani ka, mahimo. Okay? So, or you can have, kato akong giingon ganina, pwede lang ka mo consider o kini. In segment BE. Okay, this one. Muna akong giuna ganina. This one, this is BE. No? So, the shear here is 14. And this will become 0 because of the load here. The load here is the resultant of this uniformly distributed load acting over a distance D, which is still an unknown, no? So D or 2 times D. 14 minus 2D, their sum must be 0 because shear at E will be made 0. So with this, makakuha kag value which is 7. Or if not, if you apply ratio and proportion, no? So 14 is to D, correct? So the vertical side is a good. So 4 is to pila. Kini, if this is D, then that is 9. So, this is 9 minus D. Muna ako ibutang de. Okay? Now, ganang imong negative 4. So, imo lang ibutang absolute because we are taking dimensions or sides sa ato ang triangle. No? Okay, so make that absolute so you can still arrive with D. Now, in your diagram here, we are also asked to give the maximum shear, maximum moment. So, sa shear, ang imong maximum shear, ang positive is 14 kilonewton. Sa negative, doon na tayo sa negative 12. So it's still considered maximum because it is the sliding of the of the portion of your beam, no, nga affected with the shear, no? If shear is positive, no, so the effect of the shear is to have the spark, no, goes upward. Okay? Pero negative ang portion sa dire, so mapadong siya pa ubos. Okay? Or diha kadapit, no? Okay, so sa moment, ang imo kunong moment, makuha nimo sa gikan sa area sa imong shear. Okay, that is why doon na kay A1, A2, A3 itong imarkahan. So you need to solve for the areas in the shear diagram. What is your E1? As a triangle, no problem with the area of triangle. 1/2 base times height, so it's 1/2. Base is 3, the height is 6. No? So it is an area below the reference, so it is a negative area. Okay, then, what else? A2. So, triangle gihapon, 1/2, base is 7 na, na-solve naman na, di ba? Times 14. We have 49. Positive region, no? Or area. Then, kini, this is 2. Because if that's 7, that's 2. Correct? So, 2 times 4, half of that also. A negative area, negative 4. E4 is also negative, no? Below. So, we have 12 by 3. So, you have negative 36. Ang ato kunong moment diagram, kuhaon na to gikan sa area dire sa ato ang sa atong shear, correct? Okay, pananglit ning ini. So you can start with 0. Okay, then you can have, no, dire. So up to what value of the area? -9 sa ingana. But you have to decide on the curve, no? So whether maging ana ba or paingon ana. Okay, og paubos, meaning concavity is downward. Og ingana, concavity is upward. Now, how about the value of your share? Is it increasing or decreasing? If that is from 0 to a negative, meaning your share is decreasing. Kung sa ito yung ingon ganina, kung ang imuhang share is decreasing, if the share is decreasing, how about the concavity? Dire. Okay, so gini. When the share is, decreasing, gini. When the share is decreasing, the moment diagram concaves downward. So, gikan sa 0, concave downward, paingon sa negative 9. Okay? So, di na ka ma-confuse atong payana ba? Mo up ba siya or down? Kaya mong tanawon ka ni Rade. So, previously sa atong discussion, you assign a value in between to find out if the curve is really downward or upward. Pero karon, we already have the idea that the characteristics of our graph here will depend on the value of our share. If our share is decreasing, then the concavity of your movement is downward. Okay, kini. This is also a part where the share from 14 to 0, so it decreases its value. So meaning the concavity would still be downward. So gikan sa -9 asa man to, kini. Ya, ito man ang imong ito is 49. So -9 plus 49. So there is 40. Diha. So 40 concavity is downward. Ya, kini na said. We have 40 and, o siya ko ipares, 83. Minus 4, what is 40? Minus 4, so it's 36, no? But if it is 0, then it becomes negative, so still a downward concavity. Yan. Okay? So, what is the degree of the slope of the curve here? First degree, so gana second degree. Actually, this is a parabola. Parabola na. Okay? Now, kini, unsa may imuhang slope ini. So, this is having a slope of 0. So, the degree here is 1 higher. So, that's why you can form a line here. So, from 36, no? What is your E4? It's also negative 36 because it will close to 0. So, nga na. So, kung 0 degree, then this can be, so, manis yan, first degree. Align. So, as easy as that, no? So, dali na ka makapurma. You can easily form your graph by just looking on the first load. You solve for the reaction, then out from the load you can produce the shear, and if your shear diagram will cross through a point wherein di nimo ma-identify what would be the value dire, then you can solve it, no? By just having shear diha imong i-consider, then tanaw ang amount of load diha nga mo 0 siya. Okay, sometimes you can apply ratio and proportion. Okay, so we have the next example. Okay, so we are also asked to determine the maximum moment. Where is the maximum moment? The maximum moment is dire 40. That is 40. This is a location where shear is 0. Okay, so we need to know where is the point where shear is becoming 0. Okay, now kini, there is also a negative moment dire which is -9. Is that also a location of a 0 shear? Yes, because from -6 to 14, so it will pass through a 0. So that's why there is also a negative, or there is also a maximum moment which is negative. The binding is paingana, o sa itong binding, paingana, then paingana. Okay? So that is when you consider your elastic curve.